So, before spring break, we were working on unit 5. We're going to stop halfway through the lesson. Not ideal, but it is what it is. So we started working on solving equations, and what we were doing was 2 steps. I'm going to go over all the steps for you so you can remember it all. All right. It's called 2 steps because there's typically 2 numbers you want to get rid of, but often takes a lot more than 2 steps to do it. All right. So to do these, let's go to the second page. First thing we want to do is look at the side with the x. So when we talk about sides, we split at the equal sign. All right. We split at the equal sign. That's the first thing you do to help focus our minds and our eyes. We cover up the side that doesn't have the x, and we look at all the other numbers on that side. So the goal is to get rid of all of those numbers. So there's a 4 and a 2, and we want the x, which is called the variable, sitting there by itself at the end. That's called isolate. So now you have to make a choice. And you get rid of the 4 first, or you get rid of the 2 first. Now there's a suggested way, because you can technically do any one you wanted. Right? Do you remember what I suggested, which one to get rid of first? Does anyone remember?
The one without the variable.
The one without the variable, right? The one without the variable tax, the one that calls the constant, right? And that one, to get rid of these numbers, we always do the opposite calculation. Either add or subtract or multiply or divide, depending on what's going on. So you go, okay, what's the operation between the 4 and the x? The 4 is being added. So the opposite of adding is subtracting. So that's how we get rid of it. So we get rid of things by either making zeros or ones. So when you're adding and subtracting, the goal is to make 0. If that's a positive 4, we have to go minus 4. It means 4 minus 4 is 0. So when we're adding and subtracting, stack them above each other. So once on this side, once on this side. So keep a mirror image going, right? Now we do our canceling. So our 4 minus 4 is a 0, so that's why that disappears. And we're left with a 2x. On the other side, what do we have? 1. Okay, so going through all of these steps, then we cover it up again. Are you okay? We're down to just 1 number left over. How do we get rid of that 2? Right? Dividing. It's 2 times x, and when we're dividing, I want you guys doing fraction lines. So fraction line, divide by 2. Right? Fraction line, divide by 2. Whatever you do one side, you got to do the other. Okay, then we do our cleanup. 2 divided by 2 is 1. That's how they cancel. So when you're canceling, you're either making zeros, when you're adding and subtracting. When you're multiplying and dividing, you're making ones. So you're left with the x. Kira, shh. Turn around, put your legs down. And you're left with just a half. So x is a half. And that's it. Do I need to move you? That's your next step. All right. All right. Second, is that coming back? Slowly. All right. Some of them are trickier than others. Let's go for. Oh, none of these are too bad. We're not going to do all of those, so we can go straight into the word problems. Let's do 2 more questions, and we'll go into the word problems. Okay. Split at the equal sign. It doesn't matter that the x is on the other side, so we just cover up the side that doesn't have the x. Okay. Next, you focus on the 6 and the 5. Which one are you going to get rid of first?
6. Negative 6.
So it's negative 6. You look at the sign in front of it. So that's a negative 6. Opposite of negative 6? Positive 6. So you go plus 6. Once to this side, once to this side. So the 6's cancel each other out. It's negative 6 and plus 6 makes 0. On the left side, we have 7 plus 6, which is 13. What do we have on the right-hand side?
5.
Negative 5x. This subtraction sign belongs to the 5. We didn't cancel it out. So this stays. So we're left with that and a 5x. Okay. Next up, we cover this up again. So we're always covering up this side. Okay, how do we get rid of that 5? Divide it. Because we're looking at the operation between the number and the letter. Between the number and the letter, it's a times. So the opposite of times is divide. So you go divide by not just 5, but -5, because we want to get rid of the negative sign as well. You cancel these out, and we go cancel, cancel. We're left with the x, and just 13 over 5. You just move the negative sign up to the top. That's it. Okay? All right. Let's go for... Let's do this one. Last one, then we'll do some word problems. Okay, split at the equal sign. Now we have 3 numbers we're trying to get rid of. Right, cover up the side that doesn't have the letter. 3, 2, and a 5. Which one goes first? The 5, the constant, not attached to the variable. Add or subtract to get rid of that 5? Add. It's -5. Opposite is +5 on this side, +5 on that side. -5 and +5 makes a 0. That's how they cancel out. You're left with a 14 on this side. On the other side, 3x over 2, the equal sign. Okay. Now, with the 3 and the 2, you can do it in 2 steps, or you can try to do it in 1 step. I encourage you to try to do it in 1 step, right? So, to do in 2 steps, you'd go, okay, let's divide by 3 to get rid of the 3, and multiply by 2 to get rid of the 2. But there was a other option, is we just set up a fraction. Cancel the 3 and the 2 all at once, right? If I want to get rid of this 3 that's sitting on the top, I'm going to multiply by a fraction. Do I put the other 3 on the top or on the bottom? On the bottom. Because a number on the top cancels a number on the bottom. Because what we're doing is 3 divided by 3 is 1. We're making that 1.
0. Or 1.
Up here? Not 1,
2.
but 2. We want to get rid of the 2 at the same time. So you put the 2. Okay, so now what happens is students do a really good job of this, and they go straight to canceling. And what ends up happening is when you go straight to canceling, you forget to do the same thing to the other side. Right? Before you start doing your canceling, do the same thing to the other side. 2 over 3. That's what we put on. We can put on the same thing to the other side. Now, since this isn't a fraction, to help us, we can go 14 over 1. Okay. Once we've done it to both sides, that's when you begin your canceling. All right. So you go 2 on the top, cancels a 2 on the bottom. A 3 on the top cancels a 3 on the bottom. You're left with just the x on the other side. Right? Rules for multiplying fractions. Multiply the tops together. 14 times 2 gives us 28. 1 times 3 gives us 3. Oops. 3. And that's it. Do we need to do another one of those? Or is that?
Yes.
Yes? Oh, yeah? Okay, let's do this one. Okay. Okay, split at the equal sign. Cover up the side that doesn't have the letter. Right, Cameron? 2, 7, and 3. Which one do we get rid of first?
3.
3, the one without the x attached. Okay. Now, plus 3, minus 3, what do we do? Minus 3, because we're trying to make zeros. It's positive 3. Opposite of positive 3 is negative 3. That's going to make our 0. But before we do our canceling, we've got to make sure we write it down on the other side as well. Okay. We've got it written down on both sides. We do our canceling. Those cancel away. Right? And we're left with a 2, 7. And we're left with a 3 on this side. And I encourage you, I don't know, it's not necessary. I like to put the x to the numerator. I think students make less mistakes with it. But you can leave it off to the side like that. It means the same thing. So if you're given choices, I suggest doing this, but it doesn't really matter. Right? Just how comfortable are you seeing numbers in different formats? That's all it comes down to. Okay. should we do this in one step or two steps? Next part.
One.
One? All right. So we want to get rid of the 7 and the 2 at the same time. All right. So they're both attached to this x, so we can get rid of them at the same time. To get rid of the 2, do we put it on the top
Bottom.
or on the bottom? Sorry, right?
Bottom.
Bottom. 2 on the top gets cancelled by a 2 on the bottom. That means the 7 has to go on the top. It's a mirror image. So the same thing onto the other side. Before you do your cancelling. Okay. Okay, now we do our cancelling that we have written on both sides. Number on the top gets rid of the number on the bottom. We're left with just the x. On the other side, we do our calculation. 7 times 3, 21. 1 times 2, 2. That's it. Now for the word problems. So, all of these word problems, for the most part, are going to follow a similar formula. Okay? This formula is called a linear equation. You're going to see a lot of them last year. The scenarios look a lot different, but it's always going to look the same way, the formula. Now, I'll talk about it as we read through this. So we have Enrico delivers pizza for Pepe's Pizza. He earns $15.60 plus 60 cents for every pizza he delivers. So if you want to make $30, how many pizzas does he need to deliver? Right? So we need to come up with an equation for this expression. We're going to come up with an equation for money. So I'm just going to use the signs, dollar sign. So the money he earns, how does he earn money? Well, it comes in two different formats. He gets $15.60 for just showing up, right? So he gets $15.60, right, for just showing up. So he gets that. Then he gets money for delivering pizzas. 60 cents for every pizza he delivers. So is that going to be adding 60 cents a pizza, subtracting 60 cents a pizza, multiplying, dividing? Adding, right? Every pizza you earned is 60 cents. So if I go plus 60, right? That's how much money he'd make if he delivered one pizza, right? How do we change this? So because we don't know how many pizzas he's going to deliver. If you were to deliver 2 pizzas, how much money would we add on?
120 cents.
120 cents or $1.20. 3 pizzas.
180.
180. You're just multiplying this number by how many pizzas he delivers. We don't know how many pizzas he's delivering, so this is where we have to use a letter. Times, how about the letter P for number of pizzas? So use it, avoid using X's everywhere. Use meaningful letters. Right? So just 1 pizza, 0.6 times 1, 60 cents, 2 pizzas, double that, 3 pizzas, triple that.
Do the
Right?
brackets?
You can put brackets there if you want, it's not necessary. Right? Okay, so now it says he wants to make $30. So that $30 is how much money he wants to earn. So that goes here. And everything else stays the same. There we go.
What about if we divide 30 for 0.60? We cannot divide.
We can. So, but there is a strategy we're going to use first, right? So we split at the equal signs. We want to figure out how many pizzas he needs to deliver. You go like this. Cover up the side that doesn't have the letter. Which number do we try to get rid of first?
1560.
1560. And it's adding or subtracting to get rid of it?
Something.
Subtracting. So we go subtract 1560. 1560 here. 1560 here. So those cancel out. So 1560 on both sides, subtracting. Right? You go 30 minus 1560, it's what's that? 1440. Right? So you're left with 1440 here. Those 60s cancel out, and you're left with the 60p. 0.60p. Okay. Now, we go like this, we cover it up. How do we get rid of the 60 cents? Divide it. It's multiplying, opposite of multiplying, dividing. Divide by 60, divide by 60. Go this, and we have P equals, and grab a calculator for this. Grab that. Go 1440 divided by 60 cents. Get 24. So we just do a little sentence. He needs to deliver 24 pizzas. That's a lot of pizzas. I need to update these numbers to earn $30. Right? That's it. Now, I think a lot of you guys could have handled this question in grade 7, grade 8. Not like this, but just reasoning it out. You could have been like, well, if he gets 1560 just for showing up, then you go 30 minus 1560. You go. Oh, he needs to earn $14.40. Come deliver pizzas, right? If you get paid 60 cents a pizza, then you survive. But most of these kind of questions, like if you are getting stuck at writing the equations, you go back to like the logic you use. This is a very common logic, right? Like you use in grade 7 and grade 8 or something like that. So you can reason it out. But as things get more complicated, we want to have this ability, this tool under our kit. How do we create the equations? So a lot of you guys can probably reason this out. I'll challenge you to be able to create these equations, right? All right, so these equations are always going to look like something like this. It's going to look like something plus a variable times this. They're all going to look like that, right? Because this is called a linear equation, right? And a lot of things in life follow this kind of format, right? All right, let's do one more of those and another question, and the rest of the class will be working on an assignment. Yeah. Okay. The cost of a banquet at Nick's Catering is $215 plus $27.50 per person. If the total cost of the banquet is $2,827, how many people attended? So you're throwing a party, right? And your budget is $2,827.80. How many people can show up, right? So me and my wife sort of did this when we were planning our wedding, right? So you have an equation you have to come up with, right? And you go, okay, oops, the wrong pen. I have my money that I can spend, right? And we went around to the different halls, and they have different fees. Like you have a fee for just renting the room, right? And this place here, Nick's Catering, goes, this is a pretty cheap room. They're only charging $215 to have that room. But then they're also going to charge you per person, right? That's right, usually for cost for food and cleaning up and all that kind of stuff, decorating. And they're going to charge you $27.50 for every person. So if you had one person showing up, your cost would be $215 plus $27.50. Yes.
But you have to times it by every person.
Yeah, because this number here is going to go up, right? Depending on how many people you have at the party. So you're going to times it by 1 if it's only one person. If it's 2 people, you're going to double that. If it's 3 people, you're going to triple that. I'm going to put another letter P for number of people. P for people. Last time P stood for pizzas. All right. So your budget for this is $2,827.80 is equal to 215 plus 2750 times P. That's right. So it's getting charged $27.50 for every plate of food that you're serving. How many people can you have attend your event if you have just shy of $3,000 in your pocket? See if you can figure this out on your own. Grab a calculator, move the numbers around. Can you figure it out? So your first move was to subtract 215 from both sides. How much did that leave behind? Did anybody do that one? 28, 27, 80 minus that? What did you guys get? Come on, I know there's a bunch of you did it. Come on. What number do you get here?
Where?
Right here?
95.
No. The step in between.
2012.
Yeah.
0.80.
0.80. Okay, thank you. Those cancel out. 2750. P. All right. Then you divide. Right. Divide. And what number did you guys come up with? 95. Divide by 2750. So you can have 95 people attend the event. So, little sentence. 95 people can attend the banquet. So lots of different scenarios I can give you, but the formulas are always going to look like this. A number plus or minus a coefficient or variable. They're all going to sort of follow this sort of format, right? The other scenario, which is going to keep on showing up this year and next year, is talking about area and perimeter. Right? So that's the next one. It says, hey, we have an isosceles triangle with a perimeter of 50.6. Right? So an isosceles triangle has one short side and two longer sides. Right? So we're going to draw a triangle. Right? So two of the sides are the same. Right? And they said the short side has 10.8 centimeters. Okay? Figure out how big the longer side is. So now, the information that they give us in the question is, they tell us the triangle, and they give us information regarding perimeter. So if they're talking about perimeter, you want to use a perimeter equation. Talking about area, you would want to use an area equation. So how do we find perimeter of a triangle, or any shape? What's the perimeter mean? Add up all the sides, right? So we don't know how big these sides are. We're going to call them x and x. So if you want to find the perimeter of this, you want to add all of them up. So you walk around the triangle, we have an x, we add it to an x, we add it to 10.8, and this equals the distance all the way around. Well, they tell us the distance all the way around is 50.6. Okay.
X plus x is x to...
Yeah, well, we have a problem here. We have two x's here. Right? We don't learn how to deal with two x's, but can we combine those two to make a single x?
Yes.
What does it become?
2x.
So remember with polynomials, as long as the variable is identical, we can add them together. 1x and 2x makes 1x and 1x makes 2x. We add the coefficients, 1 and 1. Altogether, we have two of these x's. That's all it is. Right? And you have our 10.8 and our 50.6. Then it becomes easy after this. Right? Just like what we did the other one, right? We split it at the equal sign. There's two numbers. There's a 2 and there's 10.8. Which one do we get rid of first? The 2 or the 10.8? I think, yeah, the 10.8. Split at the equal. It's plus 10.8, so we will subtract 10.8. Subtract 10.8 from both sides. We're left with the 2x over here. On the other side, we go 50 minus 10.8. First thing in the morning. I'm not going to trust my mental math. Minus 10.8, 39.8. Okay? Then we just get rid of the 2 by how?
Dividing.
Dividing, it's multiplying, so opposite of multiplying is dividing. Divide, divide, the 2's go away, and 39.8 divided by 2, since we have our decimals in this question, we're going to actually calculate the value, and not going to leave it as a fraction. So half of 39.8 is 19.9, yeah. So you can say the missing side is 19.9 centimeters.
Missing sides is the...
The missing side, or sides. Sides.
Do you do you only calculate it when it's just one has a decimal, or do you calculate it when it has two?
The general rule, always leave it as a fraction unless you see decimals in it. Or if it's like a science money question as well, right? Then you actually want the real value.
So science is better on side.